we're doing this lab on Ethernet, interface and link configuration. So this is lab 1.1. It is the very first lab on your intermediate lab guide. So we have the entry level and the intermediate level. So this is the very first lab on the intermediate level. So you make sure you open that one. The objectives of this particular lab is to manually set the line rate on an interface. That is simply the speed, the transmission speed of an interface. Then to configure manual mode link aggregation. To also configure link aggregation using static LACP mode. Static LACP mode. So LACP mode is also known as static LACP mode. Or M2N mode, because some lines might be active and others might act as backup. Then we're also going to see how to manage the priority of interfaces when we are using the static LACP mode. So the topology is quite simple. We have two switches, S1 and S2, interconnected via gigabit Ethernet 009 and 0010. So we are going to combine these two interfaces so that they can function as a single logical interface. That's the entire concept behind link aggregation. Most of the time we do this on the aggregation and the core layer in order to enhance bandwidth and also availability. Because, for example, when you're configuring static LACP, some interfaces will act as backup. So if some interfaces go down, then the ones that are acting as backup can kick in. So that's one of the advantages of static LACP mode compared to the manual mode, where all interfaces are forwarding data in manual mode. The other thing I need to mention here is, for example, when you combine interfaces, for example, this is a gigabit interface, so it gives you 1,000 megabits per second. So when you combine these two into one, into a trunk, when you combine them into an Ethernet trunk. When you combine these two, you actually get 2,000 megabits per second. So that's why we say that link aggregation actually increases bandwidth. So I hope that is clear. So that is all we want to do. We want to try out manual mode and also perform static LACP mode. Excuse me. So let's begin. I have already set up the topology on ENSP. So on step number 1, we are supposed to perform the basic configuration of the switch. Basically, we are supposed to rename the switch, and we are also supposed to confirm that the interfaces we've interconnected, their status are actually up. And in this particular switch that I've used, it's not able to show some of these parameters, but it is important that I mention this, that in link aggregation, there are some parameters that must match on both ends of the switches. One of them is the transmission rates, which is known as the speed here. So you see for this one, for example, is 1,000. So it's supposed to match on both ends. The other one is the duplex mode. The other one is the traffic control mode. The traffic control mode is, you know, switches can operate as layer 2 or layer 3 devices. So are the interfaces operating as layer 2 interfaces or layer 3 interfaces? So that is what we call the traffic control mode. So those are some of the parameters that have to work on both, that have to match on both ends for link aggregation to be successful. And of course, the other one is the number of physical interfaces. So if you're adding to an Ethernet trunk, you can't add 3 physical interfaces on switch 1, then you come and add 2 interfaces on switch 2. So that Ethernet trunk cannot be able to work. So the number of physical interfaces also have to match on both ends. Okay, so we're going to do that both on switch 1 and switch 2. So I just want us to see this. So after verifying, we are now going to change the negotiation mode. by default, switches do auto-negotiation. So we are going to undo that. Auto-negotiation enables them to discuss those parameters like the speed and the duplex mode. But for us, we want to manually configure that. So we are going to use the command undo negotiation and also specify the speed. So let me do that. So I open S1 and S2. So the very first thing we are supposed to do is to rename our switches. So I'll go to System View, S1. I also rename S2. So System View, S2. Then here we can go ahead and just display interface 0/0/9 on S1. Oh, sorry, I didn't do gigabit Ethernet. Okay, so there we are. So we can see that the state of this particular, the physical state is up, and also the protocol state is up, meaning the negotiation was successful. If the negotiation of those parameters is not successful, the line protocol is going to be down. Unfortunately, in this version of VRP, we are not shown those parameters like the speed and the duplex mode, but that is what we are supposed to change on both switch 1 and switch 2. So let's go to these particular interfaces. So we begin with interface 0/gigabit 0/0/9. So we want to first of all use the command undo negotiation auto, like that. So once we do that, we can now be able to specify the speed. So this is a gigabit Ethernet interface. It can do 1000 Mbps, but we are specifying that we want it to do 100 Mbps per second. So I'll do enter. Then if I type the command display this, I can be able to see that I've specified those two parameters. So that is what we are supposed to do in part 1 of this assignment. So I'm also going to do the same on port 10. So undo negotiation auto, and I also specify a speed of 100. So I'm going to do the same on S2. So int gigabit 0/0/9. So undo negotiation auto. Then I specify the speed as 100. I go into int gigabit 0/0/10. I also do undo negotiation auto. Misspelling there. Undo negotiation auto. Then I can do speed 100, and I can do display this to see that indeed I have configured those two parameters on those two interfaces. So also display this here. So on 10 on S1, I have also configured those two parameters. So that is really what we were supposed to do on step number 1. So we've confirmed the rate by doing the display this command, because if we do display interface, we are not able to see these parameters in the VRP version that is being used in this particular switch. Okay, so now we go to step 2. After configuring those parameters, we can now configure the manual link aggregation. We need to configure the manual link aggregation. The command to create an Ethernet trunk is interface, then eth trunk, then the number. The number of, remember you can create many Ethernet trunks in a switch, but a physical interface can only belong to a single Ethernet trunk. So this particular number simply used to define a particular Ethernet trunk. So after creating the Ethernet trunk, we are supposed to add G009 and G0010 into this particular Ethernet trunk. So we add it manually by using the command we go into the particular interface and use the command eth trunk 1. Okay, so let's do exactly that on ENSP. So I'll do quit here so that I go back to system view from the interface view, and then I'll use the command. Let me clear this. So I'll use the command eth interface int eth trunk 1, like that. So I have created eth trunk 1. Then I'm going to go into the interface gigabit Ethernet 0/0/9. Then I'm going to add it to Ethernet trunk 1, like that. So it's quite easy. Then I'm also going to go into int gigabit Ethernet 0/0/10, and I'm also going to add it to Ethernet trunk 1, like that. So enter. So I'm supposed to do the same on switch 2. So on switch 2, I'm also going to quit from there, then create interface eth trunk 1, like that. Then I go into int 0/0/0/9, add it into Ethernet trunk 1. Then I also go into int g0/0/10 and also add it to Ethernet trunk 1, like that. So now we can verify. We can verify that we've added those two. Let me clear. Those two interfaces into Ethernet trunk 1 by using the display command. So display eth trunk 1, like that. So if I do enter on S1, excuse me, we are supposed to say that this is Ethernet trunk 1. The working mode for this particular interface, Ethernet trunk, is normal. Normal is the manual mode, actually. So I'm going to show you the other one, and you're going to see the difference. Then you're going to see the operation status for this Ethernet trunk is up. The number of ports in the trunk are 2. Then we can see that we've added G009 and G0010. Their status are up. They have the same weight. So both of them in manual mode, both of them are forwarding in load balancing mode. So 50-50. The other thing to remember is that in an Ethernet trunk, you can add a maximum of 8 physical interfaces. So you cannot do more than 8 physical interfaces. So again, that we mentioned in the theory class. I hope you remember that. So we can also do here display eth trunk 1. Again, on switch 2, we can see those details as I've explained earlier. So let's go back to the lab guide. So verifying the Ethernet trunk configuration, that is what we've just done. So we go now to step 3. So in step 3, we want to use the static LACP mode. The static LACP mode. In order to do that, the first thing we have to do is to we have to delete these interfaces that we added to eth trunk 1 by doing the command undo eth trunk. So we have to delete them before we can be able to change the mode from manual to static. So that's the very first thing we're going to do. So here we go into int gigabit 0/0/9. Then we do undo eth trunk, like that. So when you do that, if we display this, we can see that we have removed this particular interface from eth trunk 1. So if we go into int g0/0/10, if we do display this, we see that it's in Ethernet trunk 1. So we can do undo eth trunk, like that. And now if we do display this, we cannot see we cannot see Ethernet trunk here. So we do the same on switch 2. So on switch 2 again, we go into this interface 9. We undo ETH trunk, then we go into 10 and also undo ETH trunk like that. Okay, so now we can quit. And now if I do display ETH trunk 1, sorry, you can see haina anything. On switch 2, if I do display ETH trunk 1, again it has nothing. Remember, you cannot delete an Ethernet trunk until you remove all the member links that you've added into that Ethernet trunk. So that again is important to remember. So after deleting, the next thing we're supposed to do is to create Ethernet trunk 1. It's already there, it's just recreating. So we will do the command interface ETH trunk 1, then we do, so it will get us into ETH trunk 1, which we have already created. Then we use the command mod. Then we specify the mod as LACP static. So let's just do that. So on S1, we will do int ETH trunk 1, then mod. So I just want to show you the two mods that are there. So question mark. So we have static LACP static, which is the static LACP mod, and the manual mod, which is the manual working mod. So now we want to specify it as LACP static. So enter. Then after that, we can quit, and now we can add the interfaces into this particular Ethernet trunk. So again, we go into G0/0/9. We do ETH trunk 1, then we go into interface G0/0/10. We also do ETH trunk 1. So let me just confirm, display this here. Okay, so we go to switch 2 and also do the same. So we create interface ETH trunk 1. Then we specify the mod as LACP static. After specifying the mod here, we can now go into the particular interface and add them. So 009. So we add this into ETH trunk 1. Then we go into int G0/0/10 and also add it to Ethernet trunk 1 like that. So we can quit. On switch 2, we can also quit here so that you can go back to system view. You are clear, and now we confirm display ETH trunk 1. So we can see that if we do display ETH trunk 1, we can see ETH trunk 1's state information. So the lag it belongs to, the local aggregation group, is 1. We can see that the working mode is called static LACP. So the working mode is static. Which other information can we see? It's up. We can also see the number of trunks, the number of ports that are in it, list active, link number 1, maximum active link number 8. We can also see the system ID, which is just the MAC address of this particular switch. And you can also see the system priority. The system priority is used to determine which switch is going to determine the active and the inactive links. So the one with a lower value is the one that is going to be the primary switch, and it's the one that is going to make the shots. Okay. So here we can see the actor, port name, the status of that particular interface, whether it has been selected or it has been backed up. We can also see that it's a 1 gigabit Ethernet, and also the port priorities. So here we can also see details about the partner and the system priority and the MAC address of that particular partner.
Excuse me.
Yes, yes.
Yes, this is Freddy Kodos. Sorry, I'm joining late, but I'm here.
Oh, okay, okay. Karibu sana. Yes, you have a question?
No. I'm
Okay.
fine. I'll catch up.
Sawa sawa. Asante sana. So,
Chakaris, these port numbers,
yes.
they are automatically configured, right?
Yes. Port numbers. Each port on your switch. Do you mean these ones? Do you mean here and 10?
After the port priority?
Here.
Yes.
Oh, by the way, they are different. I thought they were the same. What does this mean? Wow. I thought they were supposed to be the same with this. In fact, I've been thinking they're the same all the time. I might need to look into it and research. I cannot remember what this is for, what it means.
Okay, fine.
How? Okay, so after that, the next thing we are supposed to do is to set the system priority on S1 to 100, so that S1 remains the actor. So the one with the lower priority value becomes the actor. The actor will choose between active and inactive links. So the command to do that is LACP priority, then 100. So right now, let me see. Sorry. Right now we can see that the system priority for S1, we are on S1, is 32.768. So we can do the command LACP priority 100, like that. So once we do that, if we do display Ethernet trunk 1, we should see that the system priority has changed. So the system priority has changed. So this one will have a lower priority than the partner. So than the partner priority, which has a system priority of 32.768, which is the default. So after that, the next thing you're supposed to do is to also configure the priority of the interface. And this will determine the active links on S1. So they want us to change the priority on port 9 to 100, and also the priority on port 10 to 100. So let's do that. One thing again on port priority is that the port with the highest priority, if an active link goes down, the backup link with the highest priority is the one that is going to be activated. So that is important to note. But if all of them have the same priority, then all of them are going to forward data, like what we are doing here. So if 9 and 10 have the same priority, which is 100, 100, then both of them are going to be in forwarding mode. So no one is going to act as a backup really, unless we give them different priorities. Okay, so let's do that. So int 0/g 0/0/9. So you do LACP priority 100. We also go into int. We also go into int g 0/0/10. LACP priority 100. So if we quit from S1, we should be able to confirm by displaying the Ethernet trunk, Ethernet trunk 1. So when we display on Ethernet trunk 1, you can see that the system priority is 100, and you can also see that the port priority on this switch has also changed from the default, which was 32.7 something, to 100. So that is how we alter the port's priority. Okay. So what else are we supposed to do? Okay, so if we do display Ethernet trunk 1 on S2, display Ethernet trunk 1, we can also see the partner, that for the partner, which is switch 1, the system priority is 100, the port priority is 100. So I think that is the end of this particular lab. I hope you've been able to, I hope the lab has reinforced some of your understanding about link aggregation. Does anyone have a question? Okay.